Welcome to this explainer. Okay, picture this. Have you ever been walking along perfectly confident, maybe whistling a tune, and bam, you hit a puddle. But not just any puddle, a soapy puddle. In a fraction of a second, your feet fly out from under you, and your arms are pinwheeling in the air as you fight gravity. It's a totally everyday scenario, but actually, the science behind floor friction in this specific moment is absolutely fascinating. So today, we are unpacking the physics of the soapy slip and uncovering exactly what's going down between your shoe and the floor. So here is the core mystery we're going to solve today. Why on earth do we slip so much more on soapy water than on just regular, normal water? I mean, we've all experienced it, right? Walking over a patch of normal water might make you pause and step a little carefully, but soapy water? That creates an unexpectedly, shockingly dangerous situation out of nowhere. Why does adding just a tiny squirt of soap to a wet floor completely hijack the physical environment? What is literally happening right under our soles? Let's dive in with Section 1, the physics of walking, the baseline mechanics. Walking actually relies on this brilliant push and reaction dynamic. It goes like this. Step 1, your foot pushes backward. Step 2, the ground pushes you forward. Every single time you take a step, without even thinking about it, you are actively pushing your weight backward against the earth, and the earth, it pushes you right back forward. But here's the catch. That push requires a very specific physical property to actually work. And that magical property is friction. Friction is the force that allows the push required for walking. Basically, without it, there is no walking. There's only slipping. It is absolutely your best friend when you're trying to get from point A to point B. It's this invisible, scientific force that firmly anchors your shoe to the tile. No friction? Yeah, you are going nowhere fast. Moving right along to Section 2, when water intervenes, adding a sliding layer. Think of a completely dry floor as having these tiny microscopic rough surfaces that lock together, kind of like gears in a watch. Even floors that look perfectly smooth to us have these microscopic bumps and grooves. Because these microgears catch on each other, friction is high, and boom, you walk safely. But when the floor is wet, a thin layer of water physically squeezes in and separates those gears. Your grip is instantly reduced. This totally explains why you might have a little slip on a wet bathroom tile. But hold on, because it gets so much worse. Here is where things really escalate. Section 3, the main twist. Soap. Things get crazy. When soap enters the chat, it acts like a microscopic lubricant. It creates this incredibly smooth, slippery layer right between your foot and the floor. You are, quite literally, floating on liquid. Soap doesn't just sit there like normal water does. Its unique chemical structure acts as this super efficient lubricating barrier that completely smothers those interlocking microgears we just talked about. You are essentially hydroplaning. Making actual contact with the floor becomes practically impossible. Which brings us to Section 4, deep physics, the coefficient of friction. The coefficient of friction is the mathematical value that determines the exact level of friction between two surfaces. And here's the kicker. Soap reduces this value a lot. It makes the stabilizing force incredibly small. If the coefficient is high, you grip. If it's low, you slide helplessly instead of gripping. Soap takes this absolutely vital metric for your stability and just completely tanks it. You can really conceptualize this severe drop in grip when you look at the different states side by side. On a dry floor, you've got maximum grip, maximum safety. Introduce normal water, and grip drops down to a medium level. You lose some traction, but a quick reflex can usually save you from falling. But on a soapy floor, the grip absolutely plummets to near zero. This drastically lower coefficient of friction is exactly why a detergent spill in your laundry room is vastly more treacherous than a simple rain puddle out on the sidewalk. Finally, Section 5, real-life application, the danger zone. All of this physics translates to a massive escalation in everyday danger. A dry floor means safe walking. A wet floor means, hey, be careful. But a soapy floor, it is straight up like ice skating. The science behind floor friction escalates the danger level exponentially here. It takes you from a state of total physical control right down to near zero friction in a matter of inches. Seriously, like ice skating. I really want to emphasize this vivid comparison from our source material because honestly, it's not an exaggeration at all. Think about the physics of an ice skate blade gliding flawlessly over a microscopic layer of water on a frozen rink. That is effectively what your rubber shoe sole is doing on a soapy tile. The physics have dramatically shifted from a normal walking environment to a high-speed sliding environment. It's just an instantaneous loss of control. So, I want to leave you with this one final thought. The next time you see soap on the floor, will you remember the pure physics at work under your feet? Every single step you take is this quiet, ongoing negotiation with gravity and friction. Knowing the science behind floor friction isn't just some fun trivia fact. It might actually save you from a really painful fall. Stay curious, always watch your step, and I really hope this explainer gave you a whole new appreciation for the invisible forces making something as simple as walking possible.